parallel lines, you have proportional parts that it splits it into. So first off, I want to go over a mid-segment. The mid-segment of a triangle is the segment that connects the midpoints of two sides of the triangle. Okay, so if I have two sides, RT and TS here, and X is a midpoint and Y is a midpoint, XY would have to be the mid-segment of triangle RST. Okay, so if these were midpoints, I could say XT, the segment here, is equal to RX, and TY is equal to YS. Okay, because those points are midpoints. How many mid-segments do you think will be in each triangle then? I heard somebody say it. It's 3. Okay, so there will be 3 mid-segments in every triangle. Okay, because you have 3 midpoints. So there would be a midpoint on RT, on TS, and on RS. And then you can connect each line to those midpoints. So there would be 3 in each triangle. So looking at the triangle mid-segment theorem, that states that a mid-segment is parallel to the third side and is half its length. So in the triangle above, XY, so our mid-segment, would be parallel to RS, that third side there. And XY would be 1/2 the length of RS. Okay? Or to find that mid-segment, we can just take that length of RS and divide it by 2. And vice versa. If we're given the mid-segment, we can multiply it by 2 to get that side that's parallel. Okay, so we're going to do a couple examples of that. So JH is the mid-segment, okay, of KLM. And we want to find the value of X in each case. Okay, so JH in number 1 here is the mid-segment. That means LM is parallel to JH. So I can take the length of LM, which is 30. And to get my mid-segment, I just have to divide by 2. So JH or X would be 15. Okay, number 2 is just the opposite. This time I'm given the mid-segment of JH is 9, and I have to find that side parallel, so that entire length there. So I can take my mid-segment and multiply by 2 to get that one side that's parallel. So our X value would then be 18. Okay, the last one, number 3. I have this length right here is 8. This should say that that is a midpoint, so these two are congruent to each other, meaning L to this point here is also 8. Okay, so to find my mid-segment JH, my whole segment here is 16. So I'll take 16, divide it by 2 to get my mid-segment of 8. Okay, not super difficult finding that mid-segment or the line parallel in that triangle. Any questions on those problems? All right, then we're going to go into how to set up proportions with parallel lines. So So we have the triangle proportionality theorem that states in any triangle, a line parallel to one side of a triangle separates the other two sides proportionally, and that converse is also true. So converse again, meaning you can read it backwards. So if I have XY, that line is parallel to RS, then I can write out some different ratios that are going to be the same. So I could say XT, this length right here, is proportional to RX. Okay, so since these two lines were parallel, those two sides are proportional. Or, again, since these two lines are parallel, that means these sides are proportional. So I could write out TY over YS. Or another way, I could take one of the smaller pieces, XT, over the entire side, okay, of RT to write out a ratio. I'm going to show you another example below that'll make it a little bit easier to look at. So with that converse being also true, if I could set up this equal proportion here of Rx over Xt equals Sy over Yt, then I could say those two lines are parallel. So if those ratios are the same, those lines are parallel. That's your converse. So if you notice at the bottom here, I have these three parallel lines. Okay, I'm going to draw in just two lines here that would intersect at some point. Okay, they do have to intersect at some point, meaning they would create that triangle, and then this triangle proportionality theorem does work. Okay, so all of these lines that are here are parallel to each other. So those three lines are parallel, so I'm just going to draw those arrows in. And I'm going to label each of my segments. So this first segment here between these 2 points, okay, so that first segment between those 2 points, I'm going to label segment A. Okay, then between these 2 points here, this segment, I'm going to label segment B. Then over here, on this line, between these 2 points, is segment C. And between these 2 points is segment D. Okay, I'm going to show you how you can write out these proportions. Okay, there's multiple ways that you could do this. So as we go through practice problems, you may set up your proportion way different than somebody else, but still get the same answer. Okay, so the first way we can do this, since these lines are parallel and it splits it into proportional parts, our sides that are opposite each other like this, we can write as a ratio. Okay, so I could write A over C. Okay, so I went from A to C, right? That would be equal to, since I started with A and A is in this line right here, I'd have to start with B in my next ratio over D. Okay, so I can go this one over that one equals this one over that one. Okay, so since I started with A, start with B, or vice versa. If I started with C, I'd have to start with D. Make sense? Okay, another way you could do this, it's kind of like what we did up here when I wrote out these ratios. I can take A, so again starting with A, over B, since those are split proportionally, is equal to, since I started with A, that's this upper one right here, I'd have to start with C since that one's on top in that second line. So it'd be C over D. Okay? Last way. There's multiple ways you can do this. I want to show you all of them. Last way is if I take, again, I'm going to start with A over this entire side here. Okay, so from this point to this point. Now that entire side, I would need to add these two together. So that would be A plus B. Okay, so I can write a ratio of A over that entire segment length, which is A plus B. Okay, that would then be equal to, since I used A as my smaller piece, I'd have to use C in my second ratio there over that entire segment length, which is C plus D. Okay, so those are your different ways to write out these proportions with your parallel lines. The way that I usually write it out is this one right here in the middle. I usually go A over B equals C over D, just because when you look at this, since you have this parallel line here, here, and here, right? A and B, if you circle it, it looks like a ratio because it has that line underneath it. It already looks like a fraction. So I have A over B equals this fraction of C over D. Okay, that's just kind of how I look at it as I write out these proportions, if that helps you. Questions so far on the front here? All right. So, like I said, there's a converse of this triangle proportionality theorem. That's where you're just finding equal ratios. Okay, so you have to set up those ratios of your sides and make sure they're the same. Then you can say those lines are parallel. For the other one, you're already given the lines are parallel. Okay, so those are your differences there. So we're going to go over an example of this triangle proportionality theorem, okay, in order to find the value of x. So this one we're given that these lines are parallel, so we can use that theorem. So again, different ways to set up this proportion. So again, how I look at it is I take my sides here and here. I extend my middle parallel line. Okay, you see that? And I can see this ratio already set up here and this ratio already set up here. So I just have to set those equal to each other. So I can take 6 over 18 is equal to, since I started with 6 here, I'd have to start with x plus 2 in my second ratio, over, I moved to 18, so I'll move to x plus 22. Okay, so that's one way to set it up. You could also set it up where you find your entire side of AC and your entire side of AB. You could set up 6 over x plus 2 equals 18 over x plus 22. Okay, multiple ways to set this up. Now that I set up my proportion, we just do what we have been this entire chapter. We cross multiply. Okay, so I'll multiply 18 times the quantity x plus 2 and 6 times the quantity x plus 22. Okay, and don't forget to distribute your number to both terms. So here I'd have 6x plus 6 times 22 is 132. Then I have 18 times x plus 18 times 2 is 36. Subtract 6x. And subtract 36. Then divide by 12. to get x is equal to 8. Okay, questions on how I did example 1, how I set up my proportion, how I solved for x? All right, then we're going to look at example 2. In example 2, this is using the converse part of that theorem. So this time we're not given that those lines are parallel. We need to prove that they're parallel. So in triangle GHJ, HK is 5, KG is 10, and JL is 1/2 the length of LG. Okay, since I'm not given numbers for those, if I just write LG is X, right? JL is 1/2 the length of LG. So that means LJ is 1/2 X because LG is X. Okay, and we want to show that or see if HJ is parallel to KL. Now, in order for them to be parallel, their ratios have to be equal. So I'm going to set up my ratio here of HK to KG. Okay, that would be 5/10, which is what? 1/2. Okay, now I want to do the same thing with my other sides. So since I started with HK, I'm going to use JL to LG. Okay, JL is 1/2 X, and LG is X. Now if I have an X over an X, what happens? They cancel out, right? So I finish with 1/2. Okay, so since these two ratios are the same, these two lines would be parallel. So since ratios are the same, HJ is parallel to KL. So if your ratios ended up not being the same, then you'd say those are not parallel. Does that make sense? Any questions on example 2? All right, then looking at example 3, we want to look at this picture off to the right here. So frontage is the measurement of a property's boundary that runs along the side of a street, lake, ocean, or river. We want to find the ocean frontage for lot A. So lot A is this lot right here. The ocean's here. So that means we're finding this length here. So we're finding the frontage for lot A. And we're given the frontage for lot B is 60 to the ocean, and along the road is 42, and for lot A along the road is 58 yards. Okay, and in your picture it is kind of hard to see, but there are little arrows here indicating those are parallel lines. So we can use that triangle proportionality theorem to set up a ratio to solve for that frontage. So again, I just look at the one side, make my ratio using that parallel line. So I would have x over 60 is equal to the other side. Okay, since I started with lot A, and start with lot A over here. So we have 58 over 42. Okay, now that I've set up my proportion, I'm just going to cross multiply. So we have 42 times x And then 60 times 58. That's 3,480. Then we just have to divide by 42 on both sides to solve for x. And I got 82.9 yards. About that. Okay, questions on example 3. All right, then I want you guys to do problems 1, 2, and 3. Okay, you're finding the value of x. For number 3, this is a mid-segment problem. So that's like one of the first problems that we went through on the front. Okay, I want you to do problems 1, 2, and 3. All right, if you're finishing up your last couple problems here, I'm going to start going over number 1. So number 1, I set up my proportion as 5 over 5 equals 7 over x. Now, if you know that these are supposed to be equal ratios, you don't even have to cross multiply and solve. Since you have 5 over 5, you'd have to have 7 over 7 for them to be equal. But if you did cross multiply, you'd have 5x equals 35, and then you'd end up with x equals 7. Okay, so since they are equal ratios, they have to be equal. Since 5 over 5 is 1, the only way 7 over a number would equal 1 is if it was 7. In number 2, I set up my proportion as 20 over x is equal to 18 over 9. Cross multiply, 180 equals 18x. Divide by 18. I got x is 10. And then the last one I said is a mid-segment problem. So you can see that because these two pieces are congruent to each other, meaning that's a midpoint. These two pieces are congruent to each other, meaning that's a midpoint. And these are parallel, so I can just take 35 and divide it by 2 to get x is 17.5. Okay, so those are like the first problems that we did on the front. Okay, questions on those 3? All right, then number 4. Again, we're using the same theorem here to solve for y. Okay, I only have to solve for y in this one because I'm not given an x. So since these 3 lines are parallel, these 2 lines will eventually meet. It'll be somewhere further away. They're not parallel to each other. I can set up equal ratios of your sides. So again, I just take the one side, make that fraction or ratio over the other side. So for this one, I would have 5 over 8 is equal to y over y plus 2. Okay, so since I started with 5, went to 8, moving to the other side, I'd have to start with y, go over y plus 2. From here, I'm going to cross multiply, so I have 8 times y, it's 8y. And then here, I have 5 times y, 5y, and 5 times 2, which is 10. Okay, again, don't forget to distribute. Subtract 5y from both sides, I get 3y is equal to 10. Divide by 3, and I'm just going to leave this as a fraction of 10 over 3 because I get a repeating decimal of 0.3 at the end of that otherwise. So I can just leave it as a fraction. If you found the decimal, that's fine. You just put 0.3. All right, the next one is a little bit different, okay? So in number 5, you see that all 3 of these pieces are congruent to each other, right? Well, since I can make a proportion with these sides, this ratio would have to equal 1, correct? Okay, it's the same thing over each. Since these sides are congruent to each other with our parallel lines, your other sides have to be congruent to each other as well, because they have to be able to equal 1 when you set up that ratio. So if you ever see a problem like this, all of your sides equal, the other sides also have to be congruent. Okay? So since I know that these other sides are congruent, I just have to pick 2, set them equal to each other. Okay, so I'll just use 12 and x, or 2x minus 6. So 12 equals 2x minus 6. Okay, just pick 2 of the sides, set them equal. Okay, then I just add 6, so I have 18 equals 2x. Divide both sides by 2. Your x value will equal 9. Okay, questions on number 5. Thank you. All right, then I want you to do 6 and 7. Okay, number 6 is kind of similar to number 5. Okay, I want you guys to do 6 and 7 for me. Okay, I'm gonna finish up these last two problems. I know I didn't give you a lot of time, but I do want to give you some time to work on your assignment. So I'm gonna do the last two here. So in number 6, what I wanted you to notice was that you have these congruency markers here. Whenever you have congruency markers, set those two things equal to each other. Okay, so I can set 2x plus 4 equal to 3x minus 1. From there, I can just solve for x, so I'll subtract 2x. So I have 4 equals x minus 1. Add 1. X is 5. But I also have to solve for y. Well, if I know that those two pieces that had x in them are congruent and these lines are parallel, what do I know about these two sides? They're also congruent. Okay, so I can set those two segments equal. So 3y equals 2y plus 2. Subtract 2y. End up with y is equal to 2. Okay, so look out for those congruency markers as you're doing these types of problems. The last one here. Number 7 was a little bit more challenging. So I set up my ratio as 3x over 5x. Again, you don't have to set it up this way. Is equal to 12 over x plus 12. Okay, so I took these right here over these right here. Okay, I'm going to cross multiply. So I have 5x times 12. That is 60x. Here I need to distribute my 3x. So I do end up with 3x squared plus 36x. Now since I have an x squared and an x, I want everything on one side of my equation. So I'm going to subtract 60x. So I have 0 equals 3x squared minus 24x. This one is easy to factor. What do they both have in common?
4.
Not 8. 3 and x. So factor out a 3x. What do I have left from the first term? X. What do I have left from this one? Okay, then I just have to set both of those equal to 0. So set 3x equal to 0 and x minus 8 equal to 0. I end up with x equals 0, x equals 8. Can I have x equals 0?
Yes.
If I plug in 0 for x here, this side length is 0.
No, you can't.
So I can't have 0 as my answer. But I can have 8. Okay. Ignore the part at the bottom. I forgot to delete it. I made that assignment into your worksheet instead.
Yes.